Hello guys, so in last video we saw how to implement the simple data handler. We had created another data handler that used to uh, convert our data payload from the response to a Java object so that we can use it in the further processing. So I think that is the concept that I wanted to teach you. Like not everything that we do in the Java will be using strings only. That's an object-oriented programming. You should definitely leverage that. Using that, we also learned how to use templates. And as discussed today, we are going to implement a simple WebSocket client. Okay, so last time we discussed WebSocket is for high velocity data where you don't need to create a connection again and again. You just connect with the client or server, and then you send as many data as you want. You can receive and process as many data as you want, and that is as simple as that. So we'll get started with this. So in the consumer package, we had one dash data consumer, right? What we need to do is we'll okay, just a minute. Yeah, we'll create another class, web socket data consumer. Cool. Now that is also implement callable. It will definitely ask us to implement this method. Correct. Now for implementing WebSocket client, you need Jakarta's uh, WebSocket implementation. So let's see if we have it in form file. Uh, the strip event. We don't have that here. We can create one. Jakarta's HTTP or ticket client. I'll get to that. And these are APIs. We need a concrete implementation for these APIs. Cool. Doing refresh. Let it refresh. Okay. So we have, I think, everything ready. We have implemented this one. What I'll do is this web socket client dependency. Cool. Now, if this is the thing, I'll implement logger as first thing, private static final logger logger equals log manager get logger. Okay, data consumer file. Cool. Now, how do you use this one? Okay, we are starting. For that, we need WebSocket container. WebSocket container equals need container provider dot WebSocket container. Cool. What we'll do is we'll use this container to connect to the server. Okay. I'll where is point get API. We'll open WebSockets. This one, I have this WebSocket documentation. In that, they have given us this trades and prices. Cool. If you can see, this is what we are getting. IntelliJ. And for this, connect to server, you need a implementation class like what to do with this messages, and I'll create URI dot create. Cool. This requires one more argument. Okay, what is this argument? This is nothing but what to do with the messages that we get, and what should we return. So we'll implement this class, uh, endpoint class. Cool. So what we can do is we can create another pocket endpoint. Okay. Simple socket endpoint. It's a public static class. We'll use client endpoint. Okay. So basically it is defining this is my client endpoint, private static final logger. We'll import this classes. Correct. What we'll do is we want to create one method that will definitely handle public void on message string log.info on message. Correct. This much simple. Now we'll do this and add it here dot class. Okay. We'll definitely say ignore auto closable. No, I don't want to ignore auto closable. I'll say try. I'll assign a variable session session equals state. Now we'll keep this running. and we'll catch any exception. Cool. What does it say? Add a return variable. We can return null. Okay. Anyways, we are not going to this part. So now we can implement this one as well. Copy the name. This is our app. We have this method get rest data consumer. We can definitely create one more public static collection get web socket data consumer list of new web socket data consumer. Correct? What will use this one right now? Not that one. Now let's start if it's working or not. See, we started receiving message. We have established a connection, and you can see at this rate we can get the messages from WebSocket. So consider if we want to get this much high frequency, I mean high velocity data from an endpoint. Definitely, if it's a REST call, we are definitely making REST call every like uh, second or maybe even like much faster than we can think of. Maybe two or three requests in a second. That's an overload in the server side or maybe client side as well to like just keep creating connections and keep closing connections. So this is the point. Create one connection and we open entire duplex message transferring protocol. So we can transfer message from here and there. Now in this WebSocket, the CoinCap WebSocket connection does not require us to send any message back. So it is just sending us the data messages that we want to process. Correct? So you can see this is the WebSocket data consumer. We had created this. We started with start WebSocket data consumer. We started the session, and the session we had said, okay, what are messages we are getting that should be handled using this one client endpoint. On messages, we'll be using this. Cool. So it is logging received messages. So now that is what we are going to do in the next step. We have started consuming the data from the WebSocket. We'll definitely make this even better. This is for the understanding. We have just sake of this and explanation. I created just simple logging one. What we'll do is we'll just refactor this code a little bit. We'll start a Kafka server. We'll create this uh, Kafka producer in our code, and we'll get these messages and push those into the Kafka uh, topic. So that is what we are going to do. So let's start with this now. I'll close this one. Correct. So what is the scope of improvement? First of all, this one. Correct. If I want this WebSocket consumer to be used for any other data point, definitely I don't want this to be hard coded here. And then this one, URL. Correct. So what I'll do is private final string URL and then private final class and point class. Okay, we don't have this, we need it in the constructor. We have created one constructor. I'll change this one. Get WebSocket data consumer. And this one, first is URL, second is this. So we had one constant uh, post WebSocket WebSocket post. What was that? WebSocket concap.io. visit the configuration. We want to change it here. We'll use string. Okay. Then app constant public, that is final socket endpoint. I'll name it something like price socket endpoint, and cool. Let's say we want only Bitcoin, correct? So now we have config object WebSocket host plus constant price. Okay, cool. This is simple. Now let's try this. If you are missing anything, okay, we started getting there. Correct. Nothing's wrong, but we are still getting all of this because we have not changed this. I'll put my URL here and I'll put my endpoint class here. Now let's start. Okay, now we should be consuming all only Bitcoin messages, only Bitcoin price. Okay, cool. Whenever there is a price change in the Bitcoin, WebSocket is directly sending us the messages and we are consuming it in the real time. This is cool. Cool. Now the second part. We'll create one Kafka. Okay, first I'll do Spotless apply. Okay, our code is well written now. Now the second part. Well, in this next part, we'll have to create one Kafka producer, and we'll definitely create one socket endpoint for Kafka producing. Whenever we are getting these messages, we'll put it into the Kafka topics. So we'll go through how we can set up a local Kafka and what we can uh, do with our code to start consuming this message and put it into Kafka. So like that can be a uh, source of message for some any other application. Cool. See you in the next video. Guys, in the last video, we had implemented WebSocket client, and using that, we were able to consume data from CoinCap consumer, CoinCap API, and we saw we were getting like all of the asset classes real-time price, and at last we had put it in the only, like we started the application for only Bitcoin. Definitely, you can change the asset type to a list of assets we want to get the price for, or maybe you can just write all in capital and it will give you all the real time price data from the exchanges. So that is the thing. Now we have completed the WebSocket client implementation. The last thing that we need to do is just getting this data and put it into the Kafka, because for the WebSocket data consumer, we had just created one simple data consumer. Okay, so no, there wasn't a data. No, we created one data consumer, and unlike other REST data consumer, we did not explicitly define one data, and but we actually created one simple socket endpoint. But we'll create one more for Kafka. Actually, I'll refer to this because I got this an error. I'll say it's a socket endpoint. Yes, file is renamed. Okay, so in this video, we'll start with the Kafka installation. And actually, I have already created this Kafka, and so I'll not be creating it. But if you go and see the GitHub repo for this project, I have list down the commands you need to run to start the Kafka in your local machine. So for that, the prerequisite is also uh, listed down in the repository. You need to install Docker in your system. If you want to know what is Docker, what do we do with Docker, then you can definitely find it out on your own. That's not a big deal. That's a very simple thing. But I'll say using Docker is the one of the simplest thing to do if you want to install Apache Kafka in your system. Because otherwise, if you go ahead and check the Apache Kafka script shortcut, it will definitely give you some um, binary files, and you can start using that. But you don't want to get into that much. So what you need to do is just open Docker. Once you open the Docker, okay. Uh, depending upon your system, you can start Docker commands, Docker version. See, I can write Docker versions. Okay, so here I listed down the commands for you. Okay, this one will start a zookeeper. This one will create a network for Kafka, and this will create a Kafka server. And we are using Bitnami Kafka images. So if you want to find out about this image more, then you can definitely this one. See, search for Docker, Bitnami, Kafka, and you'll get the link on the top, and you can definitely go ahead and check this out. Okay, so now with this, we have created one Kafka server. That's your job to do in your system, and just creating the Kafka, just creating the Kafka server is not. Uh, it's not the all thing that you need to do. You need to create one topic as well, and that is your homework to go ahead and search for. Maybe you can go through this. Uh, maybe you can go through this documentation and see like how can you create one Kafka topic in your local Kafka server on the Docker. So maybe if you can find that, and if you cannot find that, please comment down and I give you the command to create that Docker topic that will be using. So if you want to use a topic name ABC, whatever you command you give, you use the topic name correctly. Here will not be using that something random ABC thing, but actually we'll be using a particular topic, and that particular topic will go into our configuration file. So make sure whatever topic name that you give is remembered by you, and even before that is the best thing. Like even before you start creating a topic, you can just write down the Kafka topic here and just use that one only. So what I'm doing is point cap, real time, price, data. This will be my topic, and I have created it. I don't need anything else, just topic name. And if you want to create a Kafka, if you want to connect with this Kafka, then you'll definitely need Bootstrap server. Bootstrap server. Okay, that will be Kafka server or maybe local host 9092. So this one will match this thing. That 9092 will match this thing, Kafka listener. Okay, cool. That's that's it, and you are good to go. So this is basically Kafka listener for plain text. It's listening to port 9092. Cool. So now we'll start with the we'll go ahead and start the implementation for our code. Okay, it's going to be real simple, real quick code, nothing fancy. We'll start we'll start with implementing Kafka client. Okay, Kafka client as in I will be adding a Kafka producer for our code. So for that you need Kafka dependency Kafka client tool. Now if we reload, I'll create one more package for Kafka. There is Kafka. I want to type this multi-factor plus Kafka thing producer. Let's again first thing first, private static final logger everything good. Give the input. Then we want one private. See, I'm making this static Kafka producer. I'm making this static because our code practice will be making this singleton. So we don't want X number of Kafka producer in our code. We'll be using singleton practices. So private static config option application config. Okay. Now public static synchronized void initialize. Okay, application config should be configuration page. We don't need this and this one. Okay, but so this is the property uh, that we are passing, and will only work if the Kafka producer is not even initialized. So we'll check object is null. Kafka producer can only can do this. Okay, signing my application configuration this. I'll create Kafka configuration this, and what I'll do is properties equals to new properties property dot put producer. See, like most of the configurations, they have defined keys, and you'll find it in producer config. So first we need is bootstrap server configuration. Okay, that we can get from for whatever changes we had in our configuration file, the Kafka topic and one bootstrap server. We want to make similar changes here as well. String Kafka config string bootstrap server. This would write bootstrap server Kafka topic. So this one will get config dot bootstrap server properties dot put key deserializer. I would rather not write it this way. What I'll do is string serializer.getClass.getName is and the same for value serializer. Correct. So we need three things: Bootstrap server, one configuration, uh, one serializer, one value serializer, one key serializer, and then we have our Kafka producer equals to new Kafka producer using properties. Okay, so now using this we can initialize. Correct. Now, using this class, we'll be able to send the messages. So what we'll do is public static synchronized void send data. That should be normal for sure. Null string data. Even before we start sending, we definitely want to check if Kafka is null, or we can say or object is null application configuration. Cool. It's all good. Now what we'll do is we'll create one producer record string string producer record equals correct. Now Kafka producer dot send producer producer record correct. See what does it do? Record metadata dot send dot get. Okay. Even before that is record metadata dot has offset that we need to check. Then logger. Okay, this logger is more than enough. To Kafka with offset application control Kafka topic. Cool. So using this we can send the messages synchronously and public carry void no if not like close the application to need it. So now this is what we have completed. So using this code, now we can create a socket endpoint of the Kafka producing WebSocket, which will definitely get these messages and it will put it into Kafka. The socket endpoint, Kafka, I'll say Kafka producing socket endpoint. Okay, definitely it's client endpoint, private, static final logger, private, static final. We want an object mapper as well. I'll tell you why do we want object mapper, because I'm not going to like put this messages directly into the Kafka. The concept is like even if you produce a message in the Kafka right now, not necessarily the consumer will consume it at the same time. So what we are going to do is we'll create a time-stamped carrier, and using that we'll put this data into the timestamp carrier, and using that we'll put the value serial JSON serialized data into the Kafka, the timestamp carrier. Okay, so we'll oh, so let's start with that one. So for that, what we'll do is we'll open DTO, else DTO, and create one timestamp carrier. Okay, so it's a record. What is it? It's a map of string, comma, double data to long timestamp. Okay, so now public public synchronized void on message okay, logger dot info received message this logger I don't want this to map upon string of double result map equals object. Yeah, correct. Type reference. Put this put right, and then timestamp carrier timestamp equals new timestamp carrier instant. No, I'll rather use instant dot now dot get epoch seconds. Then string data equals object may provide right value as string timestamp carrier, and then Kafka and Kafka sync producer dot send data. Okay. Now don't be alarmed. We have not initialized the Kafka producer, but that's not we are going to do here. The initialization will be while we start the application. So when we start this thing, just right after this, and maybe we can initialize this one here. Kafka sync producer dot initialize config object. So at this time we'll get almost everything. So now what I'll do is I have Docker here. I have that images container already ready. So I'll start Zookeeper, I'll start Kafka server, and everything is up and running. So let's start. If we can produce this code, if this code can produce messages to Kafka. Oh, see, one more thing. what we have done is in this Kafka producing website instance, we have not used it anywhere. Hmm, I'll use it here. Now we have completed the application. So um, as I said, like the Docker installation can be uh, just as simple as the like installing any other application. Then you need to like use the Docker commands for the Kafka to start your local Kafka server. And using that, we will just test this configuration out. So basically, we have our Kafka um, running. So where is the Docker? Go to dashboard. Should be here. Okay, so we have this running. We'll start this, and what we'll do is where is everything is ready. We'll start the application and see now it has consumed the records and see records sent to this with the given offset. So whatever messages that we are getting from the say WebSocket, we are pushing that into the Kafka. But there is just one more catch. We are not pushing the messages directly as it is. Again, remember, we have created a timestamp kernel. So at what time we are getting the message, we'll be pushing that timestamp with this message. So anytime in the future that we are consuming the data, even if like after consumption we like mess things up, we'll have timestamp to get the correct order of the data. So if we keep this running, we'll definitely get more and more points, more and more data points here. So using that, this is how you can complete the Kafka producer thing. And I think this is the last part of our code. And if like in this one, we are not going to uh, cover the Docker file. Maybe in the next project we can cover the Docker file. But even before that, I would like you to like explore Docker files and what is Docker file, what is it used for, and such more things. I would definitely like you to try it out in this code snippet in the repository that I'm sharing in the comments. You will have the Docker file ready with you. I'll tell you the concept right now. So this is our application that we have created. Okay, definitely. But in the production, we are definitely not going to go ahead and start the IntelliJ application, right? That's not how it's work. So what do we do? So first of all, we have just created the application itself. Okay, we don't have any test ready. So first things first, we need to add tests. Second, we'll do a Maven clean install. Okay, Maven clean install will clean, compile, test, and package everything into one jar file. Okay, now definitely this jar file is a light jar file, so it will not contain any of the dependencies that we want. It will just compile everything that we have written and put its production classes, Java class it into that. So using that single jar file, you definitely cannot run the application. What you need is a fat jar. Okay, so go ahead and Google what is fat jar, how you can create fat jar. In the repository, you have a solution. You'll find the solution there. Uh, if I have to say like it's just Maven shade plugin, you'll definitely find it there written. It's under root form of the project. In the plugins, you'll find it here just after Spotless. So using that plugin, what will happen is when you do a clean install, not just it will create the light jar, but it will create a fat jar. Okay. So if you we have clean install everything. So this is the light jar we have created CCC 1.0.1.0 snapshot jar. When you integrate the Maven shade plugin and you do a clean install, then first the light jar is created, this one, and then the fat jar is created. And in that plugin will change the light jar with the fat jar. So then when you have Maven shade plugin integrated, your fat jar's name will be CCC dot one point snapshot 1.0 point snapshot dot jar, and your light jar will be renamed to original CCC and rest of the name. Correct? So we have the jar file ready with the fat jar plugin, Maven Shade plugin. So now what you can do is using that fat jar, definitely even in your system, you can go ahead and open the terminal. You open, you start the command like Java dash jar your jar path, and if you have created the jar and you have given the main class, and you don't need to give the main class, and you can directly give the configuration file path here. Okay, otherwise what is the other option? There is other option. You have java dash class path, then your jar file path, and then you give main class name, and then you give configuration file name. This is how you can start the application. Okay, so that is how you start the application. Definitely we are not going to ship the jar file into the production directly. What we want is a docker file. We usually deploy these things using k8s, that's container orchestration. So for that, the docker is the best thing. You create a docker image, so that's why we need a docker file. So what we'll do with the docker file is we'll create, like, we'll just define few steps there. Okay, from this is my base container image, some ubuntu and ubuntu 18 and java 21 jdk runtime we have available on that, and on that go ahead and copy my fat jar in the root path, and copy my uh, configuration file as well in the whatever environment that you want. And after that, all you need to do is just like start the application. That also you can do in two ways. You can explicitly give this command in the docker itself, or maybe you can like start the docker and do like you can do anything of any of the solutions that's available in the industry. So that solution is also provided into the repository. Definitely check it out. uh, if you have any doubt, just comment down. We'll try to resolve it as well. So go ahead. Like, I have given you few tasks to do. It will be definitely fun. It's not going to be straightforward. You might face some issues, but definitely the best thing for you to do is just like self-learn. Try to debug it. It might take hour, 2 hour, maybe 3 hours as well. It it happens to all of them. Just debug everything. Okay. So best of luck for the rest of the project. We'll definitely come with some other new projects, and we can definitely create this one with the different approach as well, different libraries as well. Definitely cover those one as well. Okay. Uh, See you next time. Thank you. Bye. Follow, share, and subscribe.